Welcome back, Senior Devs. Sean Cannon here. In this lesson, we're going to talk about setting yourself up to be known as a fast problem solver. In general, when people are coming to you to help solve their problems, that's a really good thing. It's not the same thing as getting assigned a bug ticket. It's more like when someone else is assigned a bug ticket and they struggle for a while, come to you, and you're able to help solve the problem quickly. They remember that, and that reputation will follow you. What typically ends up happening is you start spending more time helping other people than working on your own stuff. Initially, this may seem overwhelming and you may feel like you're getting distracted all the time, but the payoff comes rather quickly. For example, if you're on an agile project and they have a daily scrum, you should start to notice that when everybody gives their reports of what they worked on yesterday, more and more of the team will start mentioning your name in their report. The management teams absolutely recognize this, and you'll start to be pulled into meetings above your pay grade. The managers see you helping everybody else, so maybe you can help them as well. You become known as the problem solver, and that's absolutely the title that you want. This, of course, is in direct contrast with the title you want to avoid, which is the problem creator. So how do you get to a point where you can solve problems faster than everybody else? Well, there are a few ways we're going to cover, and none of them entail being psychic or being that dev who created the problems in the first place so you know exactly what is breaking the system. Let's start with local first development. It's a good practice to develop with an offline first approach so you can catch and reproduce issues locally without having to deploy and wait for CI builds. Developing offline forces you to compartmentalize your services, which aligns perfectly with test-driven development, something we will go over much deeper in a later module. The first thing you want to do is define the interaction points between your code and the services. For example, you can't run MailChimp on your laptop. MailChimp is a cloud-based email service. If your code is using MailChimp API, the only way you can use it locally is if you're making those API calls directly to the MailChimp servers from your computer. This is typically a bad practice, as we want SecOps to have the ability to control and track API traffic. And if you're making API calls to MailChimp from your personal computer, then you're essentially bypassing your project's network. Even if you're on a VPN, this is a bad idea, because your localhost server isn't part of a controlled subnet or API gateway. Even if you're using a tool like ngrok or something, if you're jumping through all these hoops, then I'd recommend making a complete 180 and simplifying your entire infrastructure. Imagine on your local machine, instead of making API calls to MailChimp, you spin up a simple SMTP server on a Docker container and make API calls to that instead. The one I personally like to use is called MailDev, and I'll provide a link below this module if you want to use it too. As with any tool that I mentioned throughout this course, it's just a tool and can be replaced with one of 100 others. If it's not Docker, maybe it's Vagrant, or maybe it's a port-forwarded locally run server on your computer. Ultimately, it's the abstraction and compartmentalization that's important here, not how you achieve it. I like Docker because it's easy and well adopted, but please populate your own tool belt with the tools you prefer using. So if we leverage the strategy pattern, then instead of forcing your application code to know about MailChimp, you instead create a general email service, which happens to have two strategies, MailChimp and MailDev. Imagine your email service is very simple and only exports a single function called send. When you import your email service into the file that needs to actually send an email, you'll give it a strategy, most likely from an environment variable, so it knows which functions to expose. And then you invoke the email service.send instead of MailChimp.send. The signature of the send function would be identical in both strategies, but the guts of the functions would do slightly different things based on what the underlying tools actually care about in the payload you send to the strategy. Maybe you need to rename some properties or transform some data a bit so that your MailChimp strategy can directly call the MailChimp send API, and your MailDev strategy can call the MailDev send API on your Docker container. For the strategy identifiers, your local dev environment would expose the variable MailDev, and DevOps can expose an environment variable MailChimp on the appropriate deployment tier. You can see how the separation of concerns and the leveraging of the strategy pattern can both make life really easy for you as well as give the product team an opportunity to easily try out new vendors. What if they want to switch to SendGrid? Simple, just copy and paste the MailChimp strategy, rename it to SendGrid, and change the guts of the new strategy method so they play nicely with the SendGrid API. Now, if you have a blue-green deployment setup, you can have blue sending emails through MailChimp and green sending emails through SendGrid. The underlying point here is that you don't want your application code knowing or caring about vendor code. You need to separate application logic from utility logic. Your unit test will cover your services and all the strategies, and thanks to the strategy pattern syntax, you'll be able to mock out each of those third-party libraries or API calls quite easily to get 100% test coverage in your project. So this was one really deep example, but the key here is that you want to repeat this with all the interaction points and compartmentalize services that are out of your control so that your application is fully in your control. That way, when you need to work on a bug, you can first try to reproduce it locally and either rule in or rule out huge portions of the app in an instant. If we use this email example, imagine the bug ticket is titled, "Customers are not receiving thank you emails." Well, if we try to reproduce this locally and the MailDev Docker container sends an email just fine, then we know that it likely has nothing to do with our application code at all, unless there's some conditional logic surrounding that send call, in which case we need to ensure the conditions are met in the same way locally and remotely. We know then to run our unit tests, and if the MailChimp tests pass, then it's really only one of three things. Our MailChimp test has a local assertion bug. The issue is at the account level, like maybe someone forgot to pay the MailChimp bill, or the template names changed or something. Maybe we reached our send limit for the month. There are lots of things to rule out in this space, but likely logging into the vendor tool will display some messaging as to what's up with the account. The issue is in a DevOps context, like maybe the environment variable is wrong and the production app isn't pointing to the correct strategy, or maybe it's using the wrong API key and sending emails to the sandbox account or something. Regardless of the actual bug or the actual solution, I want you to understand that how you structure your code can make a huge difference in how quickly you can troubleshoot issues and rule out possible causes. Instead of just blindly playing guess and check, you can systematically narrow down the culprits and present solid options to whoever asks for your help. I realize this might sound both super specific and super vague at the same time, but trust me when I say it gets creepy how quickly you'll start to develop hunches of what could be the cause of any given bug at any given moment, literally because you can bubble sort your way down to a few interaction points in a matter of seconds. I'll close this point out by saying that if you're working on a project that has a ton of bugs, no unit tests, no local dev, and regular hotfix deployments, you may want to just get out of that environment altogether, find another job, or move to another team. I'll cover this topic a bit deeper in the growth strategies category of this course. So, if you can't reproduce the bug locally and you suspect it's an issue with a remote environment, how can you still be the hero here? It may seem enticing to kick the ticket over to DevOps or another team, but that's not going to help you grow your career. There's always a risk that your hunch was wrong, the bug gets kicked back to you, and the other team resents the wasted time. So as soon as you can, on any given project, build rapport with the key stakeholders on other teams. Very early in every project I'm on, I try to get as much access to as many systems that I can so I can offer as much value as I possibly can to the team. Not all teams want to hand out access to just anybody, so work with them and compromise where it makes sense, like getting a read-only account. There is a huge value in being able to SSH into a remote AWS EC2 container to see what's going on, or remotely connect to a staging database to run some queries in the CLI and verify if some data exists or is missing. If direct access to pre-production systems aren't allowed, then try to get permissions to deploy a branch to a pre-production tier so you can rule out third-party integration issues. If you fully depend on other team members to do these things for you, then I highly recommend setting up a pair programming session with them on your video conferencing app so you can both solve the problem together. It's not necessarily about who gets credit for the fix, but rather it's extremely valuable to projects when multiple contributors from multiple teams share knowledge of system intricacies and nuances. If you are the one driving this effort, you will look really good to the executives who typically want cross-team collaboration more than anybody else in the project. I'll cover this more in a later module. Lastly, learn the logs. Learn where they exist, learn how they're grouped, learn how often they're updated, and learn which systems are logging and which systems are muted. For example, on one of my recent projects in AWS, I was troubleshooting an API issue and discovered that none of our Lambdas had permissions to log to CloudWatch, which explained why certain data was missing from the log stream, and it was confusing to the dev team. Another issue I ran into was when Splunk was grouping a bunch of log events that shouldn't have been grouped at all. As it turned out, AWS was sending over CloudWatch logs in chunks, and Splunk thought they were all related. This caused a lot of confusion when trying to follow a round trip with the request header because the log grouping contained multiple users that happened to be using the system at the same time frame. Try to learn the log systems as well as you can as early as you can, because with remote systems, you'll start to come up with theories and then use the logs to go one by one and prove or disprove them. The faster you can do this, the better you will look, and the happier the rest of the dev team will be. That wraps up this module. Keep growing, and I'll see you in the next one.